Hello friends, today we'll discuss the next topic in the basic electrical and electronics engineering, the star data conversion. Sometime it is required to reduce the equivalent circuit and find the resistance between any two terminals or any two terminal pairs. For that, we generally do the series parallel combination uh, method to solve the circuit. But in some complex circuit, it is difficult to solve the series parallel combination reduction technique to find the equivalent resistance. Hence, in those circuit, we have to use the star delta conversion technique. So for today's, we will discuss the star delta transformation technique. When a circuit cannot be simplified by the normal series parallel reduction technique, the star delta transformation can be used. Star is this one, and delta is this. Delta is a closed loop of any three resistances, and star is the open connection of three resistances. Uh, for this conversion star to delta or delta to star, it is a important condition that the behavior of the circuit should not be changed. If we consider the delta circuit and we have converted the delta into star, then the equivalent behavior of the circuit should be remain unchanged. For that one, the resistance between any terminal pair, let's say terminal pair 1 and 2, for delta resistance is something like x, then the resistance between terminal pair 1 2 for the star should have the same value. Then it will be have electrical equivalent of each other. So we have a three resistance Ra, Rb, Rc for a delta, and R1, R2, R3 for the star connection. These two network will be electrically equivalent if the resistance as measured between pair of terminal is same for the both arrangement. We have just done the same thing. So we have taken the delta to star transformation, referring the delta network, that is figure 1. So we have to find the resistance between terminal pair 1 and 2. For that, we have considered that the current is entering at a point 1, and at point 1 it has two paths, means some part of current will travel through the path RC, and some part of the current will flow through the RA and RB path. As the current in RB and RA is same, so these two will series, they can be simply added, while the current in the RC and this series combination is different, hence they will be parallel. Hence equivalent resistance between terminal pair 1 and 2 can be written as a RC parallel to the RA plus RB, and this can be solved by this method, means R1 into R2 upon R1 plus R2. You can do that. So here's the value of terminal pair 1 and 2 for delta will be given by equation number 1. Similarly, for the star connection, we will have the current that will flow from terminal 1, and there is no any path from where the current can flow. It will travel from one point to R1, then R2, and leave point 2. Here it is important the current in R3 resistance will zero, because there is an open circuit. The current will not flow in the open circuit, and the equivalent resistance between 1 and 2 pair will be simply R1 plus R2, because they have a same current. According to the condition of the electrical equivalency, these resistances between terminal pair 1 2 in equation 1 and 2 should have the same value. So we have done the same thing. Similarly, for other pairs like 2 and 3 and 3 and 1, equation 4 and 5 give the this condition. If we add equation 3, 4, and 5, and by some calculation, it will value of R1 plus R2 plus R3 will be this one. Now from equation number 6 and 4, here R1 plus R2 plus R3, here R2 plus R3. So if we subtract equation number 4 from equation number 6, R1 will be calculated. So in this way we have calculated by equation number 6 and 4, we are, by subtracting these two equations, we are getting R1. Similarly, we can get the R2 and R3. Thus, the star equivalent resistances connected to a terminal is equal to the product of two delta resistances connected to the same terminal divided by the sum of 3. Means if we have to find the value of R1, then it will be the value will be equal to the product of RB into RC and divided by sum of all three, means RA, RB, RC, like this one. Similarly, like for value of R3, it will be product of RB into RA divided by sum of 3. Similarly, we can find the other resistors also. We can do the reverse process, star to delta, and then value will be this one. Here, the data resistance between any terminal pair is a sum of product of star resistance, means R1, R2, R2, R3, R3, R1, and divide by the opposite star resistance. We'll see here. Like if we have to find the value of, for example, value of RC. Let's see, we want value of delta RC. Then the value will be like we have to find value of RC. Then the numerator will be same, means product of sum of product of all three, R1, R2, R2, R3, and R3, R1. But the division will be just opposite branch of that. If you we have to find the RC, then we have to divide the R3. If we have to find the RA, then we have to divide by the R1. If we have to find the RB, then we have to divide by R2. Numerator will be same in all three cases. These are formulas. It is very important to note down when three equal resistances are connected in delta, the equivalent star resistance will be given by this relation, means R star will be given by three times of the R. Sorry, R delta is given by the three times of the R star. Yeah, we are taking an example so that you can understand how we are converting the delta resistances into star. And we can do the reverse process also. These are the values as we have seen earlier. Uh, like here, this is delta resistances 3, 3, and 6 ohm. They are connected into delta. Now we have to find its star equivalent. So that is star equivalent. For example, we have to calculate the value of R3. R3 will be here. This is R3. Here will be R2. Here will be R1. So for R3, the adjacent resistance will be RA, RB in sum of 3. So the value of R3 will be the product of RA and RB, means 3 and 3, and division of the sum of 3, means 3 plus 3 plus 3. It will be 3 by 4. 3 into 3 divided by 3 plus 3 plus 6, so 9 by 12 or 3 by 4 or 0.75. In this way we can find the value of this one. Similarly, we can find the value of R1. For example, we have to find the value of R1. So R1 will be here. So product of RB into RC means 3 into 6 divided by the sum of 3. So we can do the same thing and different calculations. We can find the value of R1, R2, R3, and similarly we can do the reverse process. Means if we have a star resistance are given, so we can find the delta resistance. So formula, by using this formula, we can find the value of these resistances. Thank you.